solutions. Because we'll be graphing these, can I go here please? Because we'll be graphing these, we will actually need x and y points, so you can't just leave it as the square root of 85 or whatever. Noah Solomon has a calculator which is awesome that gives them exact decimals, the exact fractions. So he had said the answer was 3,121 over 1,000, which is fine. I'm going to say 3.12. Hopefully I get that, okay? So I'm going to fill everything in. I'm going to say x equals -4 plus or minus the square root of 4 squared minus 4 times -2 times 7 all over 2 times -2 equals -4 plus or minus the square root of 16 plus 56 all over -4. X equals -4 plus the root of, what is that, 72 over -4. Can somebody confirm those for me? So anyway, get that?
That's what I got.
Yes, good. Can somebody give me the number on the left and the number on the right, please? Yeah, Luke, go ahead.
Sorry, fraction.
Decimal, please.
-1.12.
Okay.
And then 3.12.
Awesome, 3.12. Okay. As most people have that. I hope so. Okay. Now, this is the part, if you're fading out, if you're sitting there at your head of your desk, you gotta be with us here, okay? This is actual points on the graph. What point is the one on the left going to be? What, comma, what? Luke, go.
-1.12.
Okay, Luke, that is correct. Now, the problem is, I don't know where that 0 came from. Can you explain to me, please, Luke? Can everyone else pay attention? Where did that 0 come from?
Step y.
Yeah, the first step here is going to be y equals 0. So something comma 0. So this point over here is going to be 3.12 comma 0. The reason I'm making a big deal about this, because there is someone that on their first test, let's call them Cassidy, is going to tell me the point is -1.12 comma 3.12, right? And those are both x's, they're not y's. Okay, we're feeling sorted good so far? All right, where's Spidey at? Or Spidey being the broken-legged person? I think we're at you. Okay, you don't get a choice. We have to do the y-intercept. How do you find the y-intercept, please? Yeah, no problem. How do you find the y-intercept, Lauren? You can't go. I was waiting on Luke. Yeah, go ahead. Carol? Yeah, so set x equals 0. So our original equation was y equals -2x squared plus 4x plus 7. Is that right?
Did you actually want to graph?
Yeah. Therefore, my point is going to be 0, 7. So all you need to do for this is all the x's there disappear, and you're just left with your c value with your y value. All right. I'm going to underneath here put my rest of my points. I believe the point was 1, 7. Is that right? Or negative? It's positive 1, right? No one's talking to me, so I'm assuming I'm right. Right. So there's my. Are we okay on where the 0 and 7 came from? This is 1, 9.
Where the 1? Oh, where's the 1?
I'm just putting these on here because when I graph, like I don't, you guys have all your data together, mine's spread over 4 pages. Right? We're going to do another one of these in a sec. So I'm going to show you how I expect the graph to be. Okay, and I'll leave this up here for the next few days. This is for my grade 10s, but you guys can use it the same. The rules don't change from year to year. Okay, so here we go. Oops. So luckily for me, I can do my graph paper very quickly. Whoops. Hello. There we go. Okay, so number one thing is I'll talk through this as we graph. Can I please do this, guys? Okay. Now, I'm going to, if you need to borrow graph paper, please talk to your neighbor for right now. I think most of the class has it. All right. So I'm going to put, can I please do this, guys? Okay. All right, now I'm going to take a look. Since my vertex is at 1 and 9 and opening downwards, I can put my line sort of down here. All right. Because if you take a look, because the graph's going to be opening downwards, I have no negative y points, right? So I use my ruler there. Second thing I'm going to need is, I need arrows on all 4 corners, okay? If you do a graph without arrows, that just means that it's stationary. This graph can actually technically go on forever. And we're going to talk about infinity in this course quite a bit. All right, so this is just like a little snapshot. Somebody tell me, please, Rachel, how the numbers go on a graph, please.
The negatives, like, horizontally, the negatives are on the left.
Yeah.
Positives are on the right.
Okay.
And for vertically, positive numbers are on the top, and negative numbers.
Very good. Now, remember to space out your graph. I need to make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16. Yeah. All right. I need to make sure that I can get up to 9 on the top because that's my highest value. Which nicely I can. And please use your whole graph. If you have a whole bunch of graph paper there, all right, I have to get to 3. There's no point in me just going 1, 2, 3. I want to spread it out a little bit so that the graph's a little bit wider there. Sort like that. Now, I expect this out of every single one of your graphs. Okay, it'll look like that before we begin. All right, if you're somebody who is not a strong grapher and likes to do this, graphs that look like this, don't be that guy, okay? That took me, what, 15 seconds? 20 seconds maybe. And I was talking through with you guys, okay? It doesn't take a huge amount of time on the graph, right? Okay, next let's get our points going here. So, my first is my y-intercept, which is 0, 7. Right about here. I'm going to put a circle on my dot. That's only so you can see where it is. You do not need to do that. Next, my vertex is going to be at 1, 9. Next, I'm going to point at 3.12, which is about here, and negative 1.12, which is about here. So the graph should look something like that. Okay, can anyone tell me any interesting facts about the vertex, since we finally see the graph? Tell me something interesting about a vertex. Cassie, go. It is the middle of the graph. So in the homework last night, okay, or this weekend, they talked about an axis of symmetry. Okay, so that's the exact middle of the graph, left and right. Okay, so if you actually were to fold up your parabola, it would be a mirror image exactly there. And we'll talk more about that in this course and future math courses. What else do you know about the parabola? There's one other thing that's important about a parabola. See, 3 people, or only 3 raise their hand. Someone other than Chris Weisrow. Someone else, please. That whole row's out. Okay. What else is important with the parabola? Oh, come on, guys. You gotta wake up. I know you want your math to be perfect here. Why is the parabola important to us in math? Oh, come on. Nobody knows, Emerson.
Let's say yes, is visual.
Good, yes. But why is that point important to us for a parabola?
Oh.
Taylor. Sort of, yes. I wanted a different word from that, though. Emerson.
Vertex, or like the highest it goes.
Good. It's the highest or the lowest point, okay? If I'm throwing a ball, okay, and I'm going to say, hey, I want to hit the top of the roof, okay? What about the most important thing? How high the ball goes, okay, right? I was watching football yesterday, and don't want to get into that, okay? Now, because this is symmetrical, there should be another point on the right-hand side. Can somebody tell me a point that is not been given yet? Min-Chan, go ahead. 2, 7, because it's actually a mirror image, okay? So 2, 7, there is, again, the corresponding points, right? Okay, you don't have to put that one in there, but I like to just to make the graphs look the same. Okay, if you were to give this to me as a graph, you'd be missing 3 things. Can someone be brave and tell me something they're missing? Go ahead.
The arrows at the end.
Yeah, okay. Please actually extend this graph and just go, because this graph does actually go forever, okay? Actually, if you were to go step over this far, it would be down through, down in the middle of the earth, okay, that's the T. There's one last thing I need here now. Go ahead, Karina. A title, what's a beautiful title for this graph?
You just give like the example one, but then you can just give the formula.
Example one would work. Formula would work. In grade 9, Chris would say crystalline awesome graph of awesomeness. That would also work, okay? But example one on this would work. I'm going to call this y equals negative 2x squared plus 4x plus 7. Okay? Okay, I'm going to do one more. And I'll just give you guys your homework right now. You guys want to do one more? No. Okay. I'll give you guys your homework right now. Now you have 20 minutes, so get started on it in class. Okay? Yes. That's okay, you don't need a textbook. I have. No, you don't need a textbook. Oh. Here's your homework. What do you mean, 5 questions? Yes. 5 questions. You one in the class, it should be 5 graphs homework type. Okay, I want this stuff to be automatic. Okay, I don't want to be any confusion on this. We'll be using these types of parabolas lots in this course, and I don't want you to be afraid of any of them. 4 looks scary. 4 is not scary. The scariest one here is probably number 2 and 5 are both scary. Okay, 2 and 5 are the scary ones, not 4. Okay. Yeah, 2 and 5 are the scary ones, all right? Okay, so if you want to get started right now, I will wander on a process so that nobody sees us, all right? It's all right.